Hello folks, this is Asal Alai and I'm going to be the lab coordinator for all introductory physics labs at UCO. You get this link from me, because most probably you are teaching either general physics 2 or physics for scientists and engineers 2 at UCO. From now on weekly basis, you're gonna get all these videos from me that gives you an instruction about how you run your experiment or how you run your lab for the next experiment. So first lab is all about Excel, but before I get into this part, explanation of this experiment, I need to tell you that always in this room for first 10 minutes you're going to have quiz, and a copy of the quizzes will be in your mailbox. So basically for first 10 minutes they have quiz, then for next 20 minutes you explain the procedure of the experiment, and then at the end after 30 minutes you let them do the experiment by themselves. From 2-3 weeks, after 2-3 weeks from now, unfortunately they get behind in lecture, and then you can't give them 10 minutes quiz at the beginning. It's better for you to explain the lab experiment for first 20 minutes, and then after you're done with 20-25 minutes, you give them the quiz. This way, hopefully no complaints goes to engineering physics department, and also they're gonna be happy because you grade quizzes out of 25 points, and if you give them quiz without giving lecture, their grade would not be that good. It's going to be 10 or 15 out of 25. So just because we try to help them also at the same time to understand this lab, it's better to give them lecture first. But this one, since it's all about Excel, and you already in orientation part emphasize that you need to read section 70, 80, and 90 of your lab manual. Hopefully they come to the lab ready and they can take the quiz. Okay, so after you run 10 minutes quiz, you give them little bit explanation about curve fitting using Excel. So they have already read this part, they know how to use Excel, and they need to make this lab report at the end for you. As you see, first page is called cover page, and it's already made using Microsoft Office. In fact, they use Microsoft Office Word during the class to make this cover page, and then they're going to attach 5 charts to this lab report and also conclusion. For this part, since all data are given in our Microsoft Office Excel, they don't have any experiment, but if you want, you can ask them to list all those things that they have learned in Excel. So you can ask them to write their conclusion about Excel, but for now, I'm going to show you how they run the experiment. So, okay, here is how they do the experiment. In fact, you give them explanation a little bit. They go to GPII folder experiment and they find Excel Graphing Lab. This one, they click on that one. You see that it gives them 5 separate sheets. It takes forever. You're gonna tell them be nice with these computers, a little bit slow. Okay, it gives them explanation how to begin. They push on this tab and it gives them 5 data sheets, data 1, data 2, up to data 5. So on this one, they can't do anything. So basically, they need to copy everything from here and paste it in Microsoft Office 2013. So I copy this from here, Control-C, and I go to Excel, Start, Microsoft Office, All Programs, Microsoft Office 2013, and then I open Excel 2013. Now I paste everything over here, okay? Now, I need to make a chart. Always, they highlight their data, they go to Insert, then under this one, always a scatter, and they need to make sure, since it says velocity versus time, velocity must be on y-axis, time x-axis. So when I check my data, velocity starts from 4.9 and it goes to 84. So this is my velocity and this is my time. Okay. Always you ask them to move their chart into new sheet. So right click, move chart, new sheet. So they get everything in a nice maximum resolution. Always we get rid of grid lines. So they click on this plus sign and then they remove grid lines, okay? Then we need to always display an equation and R-squared value. R-squared value is called linear regression, and they have not covered it in this course. So you're going to tell them R squared value must be really close to 1, and it shows you how well you choose your thread line. So if it's really off from 1, means your equation is wrong. For example, based on what I visualize over here and based on what I know from GPII, velocity versus time must be a linear equation. So for example, if they choose polynomial or exponential equation for this one, they get R squared value off from 1. It's going to be far away from 1. So this is how, in fact, they can check, they can play with this. They go to thread line, sorry, not thread line here. So basically, they go to, hold on, they go to format, let me see, format, okay. They go to this plus sign, thread line, and then this arrow. I choose linear, and I'm looking for an equation. So I know we used to have thread lines somewhere over here. Design, quick layout. Let me find all thread lines because I'm pretty sure it must be here. So I say format, okay, sorry. So they're gonna find this one, add a chart element in left hand side. When they go to design, add a chart element, they go to thread line here, and then they go to more thread line option. Okay, look at this. I choose the linear and I click on display equation and chart and R squared. So look at this. When I have linear equation for velocity versus time, my R squared is 0.9975, which is really close to 1. If I choose power, let me delete this. So I go to add a chart element, thread line, more thread line option, thread line, more thread line option. If I choose, for example, power, you see that I'm going to get R squared value, which is off from display equation on chart and R squared when I have, for example, polynomial. You see that my, let's say power. Let me go to add a chart element, thread line, more thread line option, power. For some reason, let me redo this one more time, okay? So insert this one, scatter, move chart to new sheet. Now I go to add element, thread line, more thread line. I choose, let's say, power. It doesn't let me play with power. Let me see. For example, I go to look at it. I don't know why it's not thread line, more thread line option. Let's say exponential. Okay. And then equation and R squared. You see that my R squared is a little bit off, 0.884, and it's not as close to a linear one. So then I know not only based on my R squared value, based on how I get my thread line, I know this is not good to choose. So they're going to choose a linear one with this equation because this is the best one, okay? Of course, they get rid of all the grid lines, and then they're going to type velocity versus time for their chart title, and then they go to axis title, and they put x-axis name, y-axis name, and then after they're done with this, they can print it out. So this is their first graph, okay? So they have also one data sheet that comes with a tool. It's one of them is resistance versus current, R1 versus current, and the other one is R2. So let me do also this one for you because this one can be a little bit complicated. This is the last one. For the rest are easy, are same with the first one. So this is the last one, and I'm going to make a plot of both of them. So they highlight everything, then they go to insert, scatter, first one, right click on their chart, move a chart, new sheet. All right, remove grid lines. Then they go to add the chart elements, thread lines, more thread lines options. So for R1, we're gonna choose for R1 thread line, more thread line option. I'm gonna choose, let's say, power with equation and R squared. You see that my R squared is exactly 1. So it's the best one that I can get. So it seems first one is, it comes with this equation, power. And then I choose the second one here. I go to thread line again, more thread line option. Thread line, more thread line option. And I choose, let's say, exponential. With R squared value and equation. Again, I got R squared value equals 1. So they do their best to find the equation that comes with R squared value closest to 1 or exactly 1. Okay, after they're done with this, again, everything is under this plus sign. Grid lines, chart title, access title. So at the end, they're going to print out something like this for last one. They're going to have all these legends over here because they have 2 graphs. So R1, R2, R1 is power, R2 is exponential. You have to be picky about access names, chart name, and also R squared value and equation. At the end of the experiment, they're going to have 5 graphs or charts attached to this experiment. First one is only one velocity versus time. Second one is voltage versus current. Third one is position versus time. And fourth one is resistance versus temperature. Last one is resistance versus current for 2 resistors, R1 and R2. So, in fact, in this experiment, we want them to learn how to play with equation and R squared value to get the best thread line that they can pass over their experimental values. Because till the end of the semester, all the time, they make measurement of something, they make a graph, and based on their graph, they need to make a chart. They need to figure out which thread line is the best thread line. So this is all they do in first experiments. It's all about getting familiar with Excel. After they're done, they turn in everything here, and then next week you have their graded lab reports and graded quizzes. Quizzes must be graded out of 25 points, lab reports out of 75 points. That's how you report their grades out of 100 points. By next week, you get an Excel sheet, your lab Excel sheet from me. Either I email it with you or I put it in your Dropbox account. I share it with you through Dropbox, and you report your grades on a weekly basis. All right, if you have any questions, send me an email or send me a text message, and I'm going to answer your question as soon as possible. Thank you so much, and see you next week.